So the next topic is particulate. It means ESP, that is called the electrostatic precipitators. So in this electrostatic precipitators, so ESP. So the electrostatic attractions. The what is meant by particulate collections. So the introduction about the ESP is the collection of devices used in industries to minimize the air pollution. So what is the main purpose, main uses or main purpose of this ESP is to the device which can be minimize the air pollutions. So this is the main purpose of this device. Then the principal operations and is electrostatic attractions. The efficiency is 99% in many industries. Then can handle large gas volumes with a wide range of inlet temperatures and pressures and dust and volumes and acid gas conditions. So and it can collect the particles varying sizes in wet and dry states. So in this, the theory of ESP is nothing but the theory of precipitations is nothing but the charging, collecting, and wrapping. So this is the first theory of precipitations: charging, collecting, and wrapping. And the second, the particle charging, that means the discharge and collection of electrodes. And the third one is corona discharge, that means the avalanche of multiplications in the ionizations of gas molecules and then particle charging mechanisms and field charging and diffusion charging and then electron charging. Then the particle collections, the particle removals, particle collections and the particle. These are the theory of precipitations. Then the particle charging. So this is the drawing. Flow drawings is nothing but the ESP, the working principles and working devices which can be used. Then the wrappers. The upper drawing is wrappers, and second one is the clean gas outlet, and then flow gas inlets, and then collection of electrodes. So this is the drawing. This portions. So in this drawing, this portion is nothing but the collection of electrodes, and then discharge of electrodes, and then hoppers. Then the electrical field strength is nothing but the weakest, stronger, and then weakest. So this portion is weakest portion, and this is the strongest portion, and this one is the weakest portions, which can be mentioned. In the corona discharge, this discharge is nothing but the positive ion, and then free electron, and then free electron, and then gas molecules. This corona discharge is nothing but the positive ions in plus conditions. In plus conditions, it should be the positive conditions, and the minus, it should be the free electrons. So these are the free electrons. So plus into minus is nothing but the discharge conditions. Then the ionizations of gas molecules. So in these ionizations of gas molecules, the particle charging, field charging, and diffusion charging, and then electron chargings. So to collect the plates and then electrons and then gas molecules and then negative gas ions. So in this negativity, the charged particles and the negative gas ions which can be used to collect the plates. So this particle collections and this particle removals by wrappings. So in this regarding the particle sizes and mapping should be affected by the removal of mappings and then particle sizing. So this is a charged particles which can be gas molecules and then electrons. Then the components of electrostatic precipitators, that means the components of ESP is nothing but the discharge of electrodes and then collection of electrodes. Then the third one is high voltage electrical systems, and then wrappers, and then hoppers, and then shell. First of all, the discharge electrodes. The electrode should be first discharged and then it should be the collected and it's for the collection of electrodes and it should be a high voltage electrical systems and then wrappers and then hoppers and then cells. So these are the availabilities. It can be the used in the components of electrostatic precipitators and we will see them discuss. Okay, this drawing is shows the overall electrostatic precipitation device which can be used in the industrial sites. So in this regard, the insulation chambers. In this drawing, the top portion is nothing but the red color is insulator chambers, and it should be the inlet. Second one is the inlet, and third one is the discharge systems, and then gas distribution screen, and then collecting plates, and then casings, and the yellow color is one is the insulation processes, the insulation tubes, insulation systems. Before this, the casing systems. Casing is nothing but the cover systems, collecting plates and then cover systems. After the collections of wrapping, it should be the discharge wrapping. Then the inspection stores and then screw conveyors and then wrapper drive stations. And it should be support divisions. That means tripod. Tripod is nothing but the support stations. It should be simply called a supportive stands. Then the discharge electrodes is nothing but the typical wire discharge electrodes and the rigid frame discharge wires. The typical rigid discharge electrodes and then flat plate discharge electrodes is used nothing but various positions. In this, the four drawings is shown. First one is wrapper and wheels and then support insulators and then discharge electrodes and then collection of plates. This discharge electrodes and then plates, a movement between the other than this electrodes and then discharge electrodes. This drawing is shows the collection of electrodes drawings. It should be used for the many devices. That means many industries like high voltage electrical systems and then transformers and then rectifiers. T is nothing but transformers or denotes rectifier sets. Then the primary voltmeter and then primary ammeter, and then secondary voltmeter and then secondary ammeter and the spark meters. So these are the high voltage electrical systems which can be used as support of insulator housings. Then high voltage bus ducts and then bus lines and transformers can should be the rectifiers. Then the wrappers. The wrappers should be available in the typical hammer and then under wrappers for collection of plates. And the typical magnetic impulse wrappers for collection of plates. Then the hoppers. The hopper is nothing but the closed positions and then openings. In the hoppers, there should be the strike plates, poke holes, and then vibrators, and then wrappers. So these are the main components of this hoppers. This first drawing in left, first drawing is shown the rotary airlock discharge devices. The second drawing is nothing but the hopper drawing, and the third drawing is nothing but double dump discharge devices. Double dump is nothing but dumping devices. I mean, you all know about meaning about dump one and dumping. So dumping the systems and the devices. So these are the different types of conveyors which should be used for the ESPs. So drag conveyors and then hoppers and then turning stations and then airlocks and hopper systems and then sliding of gates and then screw off conveyors and then should pneumatic conveyors for transportations of dust for electrostatic precipitations. So these turning stations are 300 chain and this should be the standard airlocks can be used and then lubricant systems that should be used for the intermediates of bearings. The two systems are used to hopper systems, hopper and slide gates and airlocks. Then the types of electrostatic precipitations, that means ESP divided by the tabular precipitators and then plates precipitators and then so gas flow through. plate precipitators and then gas flow through tubular precipitation systems. In this regard, the discharge electrodes and then return electrodes, the discharge electrodes and then collection plates should be used for the different kinds and then different material systems. Then the cold side area space is nothing but the volume of fluid gases that should be handled is less, and then less it should be less costly, and then overall size of the unit is smaller, and it can be used to remove the fly ash systems from the boiler, and it should be the bone higher sulfur cold systems. So